very important section and very important. And very illustrious geoscientists have adored the post of sectional president in our continuation. The president of this section, Professor Tukadoji Maharaj, need no introduction. He is an eminent geoscientist and professor of global game. He worked intensively on coal petrology. His domain of research is organic geology. He has more than 200 publications, 8 index 56, I and so with this you can reveal that his contribution in the domain of science and he is still very energetic, young among many of the presidents. He is the youngest, I must say, and I will expect much more from him in coming years. We are very happy, very fortunate to have such an eminent personality as sectional president. And you will listen to him. I request Professor Verma to deliver the presidential address. Please, Professor Verma.
New paradigms in organic petrology areas involve energy development under climate change framework. Here, there are factors, distribution, and origin that we are discussing. And the fundamental unit, that is your master, to reduce the carbon dioxide emission, we have to understand it. So here, you are aware that carbon which is present in earth is 0.36%. And if you are considering up to 10 kilometers, the dynamic carbon which can combine with oxygen and hydrogen, that is your 1 part in 1,000. And if you are considering the whole earth, it is 1 part in 13.5 million parts. And this dynamic carbon is responsible for all kinds of deposits. It is your coal or your petroleum or natural gas, coal bed methane, shale gas, gas hydrate. So here why you want to know that this dynamic carbon is very significant. We have to be very much careful in exploration, exploitation and utilization of this carbon. Another important thing about this coal, general perception that coal is an uninteresting rock and it is creating pollution in the environment. Some people may tell that why to discuss about coal just to be in the environment. But here just I want to point out the learned audience that coal is a very interesting rock. Coal can be very soft. Coal can be very hard, even harder than your coal, that is coal. Even coal can dry like barrel. There are variety of coal which you heat it, you will get whistling sound of parrot, that we are calling it as parrot coal. And here, this coal are generally considered as a black rock, but it can show variegated color like your pink of coal. Even coal can be ornamental stone. Even beautiful ladies of Europe, they wear is their bracelet and their necklace, a variety of coal that is your very kind of thing. Okay, so here just I want to tell something about coal, and you know that this coal has got heterogeneous character. Just I will tell about, you might have seen one movie of Kala Patthar, and one journalist is going to a mine, and she was Parveen Bobby, actress. She is asking a miner, how many kinds of coal you have? So that miner is telling that we have got 3 kinds of coal. So he asked that to tell me the characters of those coal. So what miner told, that first type of coal is black in color, but it is different from the 2. Then again she asked that what is the second type? Then is black, but it is different from first and third. Then she asked about the third type. So it is, again he told it is black in color, but it is different from first 2. So here what I want to tell, coal looks similar, but it has got different character. And why it is so different character? It is due to their just few lines I would like to tell about that. And about this presentation, what I am going to speak about, like your hydrocarbon generation potential of coal and cell, source and response of organic matter to depositional environment, geological and petrographic aspects of coal conversion and utilization, effects of igneous inclusions on organic matter of coal and cells, paleoclimate investigation through organic petrology, hydrocarbon generation behavior and potential of lignites. Then something I will also speak about carbon dioxide sequestration and the value addition to this coal, that is your carbon production or formation. Here the coal forms under 2 stages. Number 1 is your biochemical qualification, and number 2, under biochemical qualification, I must say that they are forming in pit mires, and there are several kinds of pit mires. It can form by terrestrialization of body of water. Like a body of water is there, by shifting it is converted to mire. And another one, that is your purification. It can form into your marine transpiration or depression. Here, due to rise of the groundwater level, this peatland is formed. And here in peatland, this organic matter can decay through 4 methods. Number 1, mineralization, that the whole organic matter is converted to minerals, that we are calling it mineralization or vibration. Number 2, when your oxygen is slightly restricted, so it is your humidification process and you are getting humic acids. Then another, when your access of oxygen is more restricted, it is converted to peat-like material. Then 4th type, that is your putrefaction or Fäulnis in German. It is you are totally forming or decay is taking place in absence of oxygen, and it is giving rise to sapropel-like material. Then this organic matter, all of us have seen coal having several bands. How they are formed? Due to fluctuation in groundwater levels, your different oxygen level, they are giving rise to different kind of lithotypes. And here, this organic matter has to go through any of the two processes, that is your vitrinization path or fusionization path. Vitrinization path is responsible for formation of various kinds of vitrinite macellars. I am not discussing all vitrinite macellars here. Then another pathway where it is slight difference is there, where interval of desiccation, dehydration and oxidation is there, and it is going to fusionization path. And there is a great difference. Here character is being said that in vitrinization path, where the conditions can change and it can switch over to fusionization path. But in case of fusionization path, it is your unidirectional path. Whenever this organic matter has chosen to go through fusionization path, it has to go through that path. Then another important thing in this biochemical qualification, this organic matter, it can remain for some time in acrotel, where it is your oxidation is taking place. Then when coal is going to carotel, where it is no oxygen is there, the residence start acrotel and your carotel decides and various kinds of products. Just I am telling you three conditions. Suppose your organic material remains for larger time in acrotel, then they are going to carotel. Some are for very period they are in acrotel and then they are going to carotel. Or in certain cases they are going directly to the carotel. So here all the products are. And in carotel, another important thing, that here anaerobic bacteria is acting on the organic matter. And this anaerobic bacteria, how they are thriving? They take the oxygen from the organic material, and that way they are increasing the carbon content in food. So here, this biochemical qualification, we are unable to identify the various macellars, and where this bacteria becomes inactive when pressure and temperature is increasing, and when there is no action of bacteria, it goes to physicochemical qualification. And here you will find that in physicochemical qualification certain changes are taking place. What are those? Distinguishing. And as we have seen, and as this physicochemical qualification advances, their shaping of the properties are taking place. And another important thing is happening in physicochemical qualification. Due to similar kind of pressure can see the various organic material, and their characters, or I should say they are, in the last they are coming to the same path. It will be more clear from these vitrinite reflectors that you can see the characters of various maceral groups, they are confirmed. And it has got a very significant aspect for coal intelligence for our country, I should say. As Westerners generally take care that you have got energinite rich coal, not bad, you have got bad coal, you will not get such kind of thing, your reactivity is so bad. But here I want to tell you, even the energinite rich coal, their characters can converge, and you will get this kind of results here about the effluent. When your coal is going through that aspect, here you can see the effluents, how they are kept. So here you can see, here you can see here also the characters of your lignite, vitrinite and energinite is converging, and how your methane generation is taking place. So when your rank is increasing, your qualification is advancing, you are seeing the generation of that methane is also taking place. So even for your coal bed methane exploration and other things, that is very, very significant part. Just I want to show you some humanite, vitrinite macerals that we have identified under the microscope, but I am not discussing those things in detail here. Here you can see the lignite macerals. They are very dry and they are accreting that coal. And these are energinite macerals. Here at 10 you can see the vitrinite. The occurrence of this vitrinite indicates that hydrocarbon has generated from this place or this material. Here also we have, I am showing you the pyrite occurrence. Now, how the hydrocarbons are generated? So here we have taken, and one thing I must tell, I have forgotten to tell, all works belongs to my students and the credit is to be given to them. That is, I am presenting their work here. So here we have taken coal samples, shale samples, and where it is heat affected or heat not affected. So how the hydrocarbon is being generated, that is shown here, although it can be discussed a lot. Here I have taken this coal and salt, and you can see that how hydrocarbon is formed. Here one source in this case is there. And now about this igneous intrusion, where igneous intrusion has taken place, you can see what the character change is taking place. Another important thing that we try to correlate those things with FDR analysis of coal. Here we have done this A factor we have taken, and S1 plus S2 under rock analysis. So just you can see that these coal samples can be very good white prong, coal or gas prong, that we can decide from that. Then I have told you about igneous intrusion. We have used this atomic force microscope and we tried to profile it. So the changes we are seeing, where it is not affected and where it is affected. So that point is there. Then some have taken on the basis of those natural assemblages, we have tried to tell about the hydrocarbon potential. So here, wire dominant, mixed wire, or major dry gas, all things we can tell through these massive studies. And on the basis of that study, that with rock paralysis, hydrogen index and oxygen index, we have delineated various corrosion types of various coal machines. Then through FDIR also, we try to tell about the various corrosion types. A factor and C factor we have taken into consideration. Then this hydrocarbon proneness. Here we have identified excellent source rock as a coal for hydrocarbon. You can see it is from Mathur. It is from Mathur and Bachelor Basin. And also we have taken even various lithotypes, nitrate, flugen, urine. What is their role? Here, just you can see the rocky valley paralysis of various types of coal. Here, if you try to see, you see the S1 here, and here is S1. By seeing these curves, even you can tell, like in here, this I am showing you, I do not have pointer. So here, you can see that this hydrocarbon has come from other sources, and that we can interpret. Even you can see the noted in S2, it depends on various type of masses and their decomposition. Here, just you know about vitrinite reflectance. Here, through vitrinite reflectance, we can tell about the source material from this P by 2 step reflectance, vitrinite reflectance. We can tell that this organic material from near same source. And in another case, you can see here in the bottom, here no peak is clear. It is from here the source material is from different sources. Even we have done reflectograms of emergenite masses, and we have delineated the environmental conditions and their deposition aspect. Then I am coming to another aspect, that is your paleophasic aspects. Here we have taken phytoclast, amorphous organic material, and paleomorphs. So that is shown here. And on the basis, you can identify various types of paleophasic assemblages. Here also. And here we have tried to establish a relationship with macerates with paleophasic assemblages. And on the basis of paleophasic assemblages, we have tried to tell about the hydrocarbon proneness. Here we have taken a whole sample and tried to see the effect of lithotypes, and we have taken nitrate, urine and fusion. Here just you can see that aspect. Sorry. So here you can see in the second diagram. Here in fusion you can see a large amount of phasement. What does it indicate? That here your hydrocarbons can be stored more efficiently. So for carbon dioxide storage, also that aspect we can take into consideration.
Yes, sir.
And then you have tried to see with the bitumen index or your production index, that relation you are seeing. I am not discussing here. Various types of macerates in lithotypes. Then this FTIR analysis of those lithotypes, you can see the change in their peaks of various types of lithotypes. Then another important thing that is very, very significant, that when we were carrying out some experiments, we could see that your hydrocarbons are not all expelled, they are retained in the matrix. And this matrix retention is very, very significant for all kind of technological processes. So here you can see the total organic carbon and the relationship with S2. Then we try to see this maceral reactivity, and that is a very significant point. Here, even your NRT9 are reactive to some extent. Now I have come to this lignites of Rajasthan. Here on the basis of this thing, TOC and sulfur content, we try to delineate various types of mires or peatlands. So here you can see how it is delineated. I am not discussing this to time constraint. And on the basis of that macerates and your carbon organic and nitrogen organic, we try to vary. We have delineated various types of plants, like you can see A, B, C, D. A is your C4 terrestrial plants, B is your C3 terrestrial plant, C marine dissolved organic carbon, D freshwater dissolved organic carbon. Then we have done this aspect also. We have taken for coal, average chain length, proxy aqueous ratio, proxy wax ratio. On that basis we have tried to tell that how the water level is fluctuating and what is your depositional conditions. Here, this figure we have introduced one parameter, paleo-redox factor, and on the basis of that, relative hydrocarbon potential, we have a delay of adsorption, desorption. We have told about various. So here, she is scientist in ASI. Then there are various pore structures and images. And on the basis of this various indices, we have identified paleo-depositional environment. Then on the basis of various natural content, we have made a granular diagram and we have taken the work of Tukadoji, and on the basis of that, we try to delineate various paleo-depositional conditions. Another thing, we have got mineralogical proxy. Then we have taken care with the maceral content and your inorganic contents about the paleotectonic settings. So here in the paleo environment condition, we are able to tell about how this condition is changing from oxic to anoxic, fluidic delta to coastal lagoon. Then another important thing, we have got organic matter. We have done hydrous paralysis of the organic matter, and here you can see that it is done at 320, 350 and 370 degree. And here you are getting hydrocarbons. So we require technological maneuvering. Even the old basins which are not productive for us, that can be made productive for hydrocarbon generation or expulsion, that we can do it. So we have got very encouraging results. I can discuss much about it here. Here, the residues left after this hydrocarbon are very brief. And during your thermal decomposition, the oxygenated functional groups escapade transferable hydrogen. Number 1 point. Number 2 point. Therefore, free radicals can cross-link and repolymerize. The availability of the transferable hydrogen increases with the decreasing concentration of the oxygenated functional groups, which enhances taking ability. Another point we have marked the inverse relation aromatic ratio. Here we have taken a Joule number can indicate escalation from taking property with an increase in aromatic unit. Another significant point, aromatic stacking reduce the internal porous space, making it difficult for the evolved gaseous hydrocarbons to leave the pore grains, inducing pressure on the aromatic framework. Another significant point, the trapped volatiles may lead to dissociate the peace bonds, and they can disrupt the cohesive molecular network information of the beta plus or chain length. So that relation we are making. And here, with increase in your aliphatic free bonds, the amounts of free radicals escalate due to thermal homolytic rupture of these bonds. These free radicals are stabilized by the transferable hydrogen sourced from the parallel energy group and other hydroaromatic bodies from the beta class. Another important part, and that is your lowering of oxygenated functional groups can lead to alleviation of hydrogen escaping, and therefore it can augment availability of transferable hydrogen to stabilize free radicals. So here you can see that what is happening in case of taking property. And here we have got a scope for a structural maneuvering or structural engineering at micro level for making non-coking coal to coking coal. Just here I will tell, we have got fascinating relation between the taking properties and functional groups, which hint towards the plausible conversion of non-coking coals to coking coals. Here, how we can do it? By enhancing the refining, branching, injecting mobile pi-electron excessive heterocycles, inducing hydrogen acceptable polyaromatic hydrocarbon. So that way we can also do that, and we have tried to see with our students. So here is petrographical taking ratio and molar relationship. And this is also that you know that the most important property of coal is your mechanical strength and reactivity of the coal. That is, and this reactivity is controlled by the mosaic content and mechanical. Thank you. Several works of review, and he has published his papers in International Journal of Review, and he is also head of the Department of Applied Geology, IIT Ahmedabad. With this, I will request Professor Mukherjee to present his lecture.
The last bench, are you able to hear me first? The last bench, are you able to hear me first? I will not need a mic. I hope I am audible. Am I audible, all of you? Yes, thank you very much. So, I find many students here, they are the future of our country, and distinguished luminaries are in the front sections. This talk is more for the students rather than our distinguished members, because they are already knowledgeable about all this, and this is a very important one to understand, that this particular topic that I am going to discuss today is today covered by one stall in the outside in the expo ground. You may visit after this talk if you need. That is called National Highway Authority of India Expo Stall. Most instrumental for the country's development, and during this development, the major aspect are roads or the transport ways that we have to design. All of you ride bikes, cars over transport roads, and you see that basically the road material which is basically done. Please don't talk. Please don't talk. The idea is, during the transport way design, sometimes feel yourself in the road, touch the road, see the material that it is made up of. You will see it is rocks, and it is minerals, sand grains, asphalt or granite material, and mine. So all these materials are bound with some ratios to develop the ballast, and the ballast are designed in the laboratory to see the load on that, so that the road will jerk and will actually keep a vibration absorbent. So when the vehicle will drive at 180 km per hour, you keep a glass of water on the seat, it will not actually fall down. Do you understand? So this quality of roads are available in the whole international market, but we don't have those. In our country, road designing and transport designing are very important. They are aspects of development of the country, and we start with this topic. But the roads which are available in Nagpur or in any other areas of the country is not the topic of today's discussion. The discussion is focused on the roads that are going to be built up in the mountainous regions. We have sensitive border lines now already, I don't want to talk on that. And the more and more infrastructure and road development we do in those areas, that will empower our country with more strength and quick logistic maneuvering of the resources facilities in the defense, in the civilian supplies, and we can actually negotiate with the high power countries in the border areas. So with this, we will just simply try to understand what this talk is all about. I have only 25 minutes of time, so I'll try to be within time. This is something that we are actually going to see about as a are you able to see from the behind? You can read yourself. A very eminent portrait by Henry Ford. US does not have good roads because it is rich, but it is rich because it has good roads. You understand? So this is the idea that we have this to be understanding about the necessity of these roads that are developed. This road is the Srinagar Leh road. Observe the road from it. Observe that the road is having a slope on the one side and a khai on the other. Did you understand? And both ways this slope is very effectively influencing this road, and the vehicles that are moving there in a beeline are at every millisecond they are at a risk of getting tumbled down on the downside because of something falling from the higher slope side. So this is exactly about how we have to do a design of the roads and try to understand where it is most sensible. So the idea is that we are having roads that are barriers to the development, and life in the Himalayas are very challenging. The last time says that the Himalayan regions in the northern side of China and Pakistan and Myanmar internal intestines are having a bit of sensitivity. You understand the seed is passed. When it turns out and you don't look out. So the idea is, if you feel like what it is going to do, observe that the road has been cut across this entire continuous mass and the passageway has been made so that the road will go through it and you will be able to see this. They are the major roads that are basically leading from one end to the other. And this is the way that we have designed the road in such a way that it will in one way give the safety and the other way this is basically going to give us the guidance. So now this road that you are seeing is a mountainous road near Tibet border, and we are going to see that the road is already made. Then within 15 days it has been totally covered by a slide. A slide has taken place already, you can see along the slopes of the mountains, and then again reconstructed. Roads are born and killed in a mountainous way, naturally. And every time the Border Road Organization in the country is working 24/7 to reactivate them and make them. Now this is the roads that are basically developed in the mountainous areas where rocks are falling down as boulders on the road, and they can be of different types. Roads in general, when they are dangerous, they need to be lengthened to negotiate steepness. You see the earlier roads that are basically having a stairway rise has been now lengthened far towards the other end and then come back on the top so as to attain the gradient. And these roads will obviously be constructed in areas of rock which will have certain aspects of development. How it is done? This is the Komatsu road excavator which is mounted on that elevation, and it is now gradually excavating the materials in front of it. It will excavate and throw up the material and will advance it. Again it will excavate the material, again it will advance it. You understand? So the road will go on developing. But during this excavation, the vibration made, the shocks develop, and the rock's own properties inside might suddenly entirely throw the whole machine outside and can throw it deep inside the areas where it cannot be found anymore. So this is the areas of road challenging constructions, and we will understand the geology behind it, and that is exactly the subject of this talk. Now we'll see that this in Taiwan, the road which is basically a highway, very highway, speedway, has been totally covered by sudden flows of the slopes which have come down from the other end and have totally devastated the road altogether and have entered into this. Now the idea is this: sometimes this material which is falling down may be a mass of soil and clay and many other things. Sometimes that may fall down as large boulders of rocks. So these boulders that you are seeing now lying in the road are basically covering the entire terrain in order to understand that this is going to be happening. Now principally, if we look at the major topic of this subject, what really controls these failures of the slopes that devastate roads that are made with so many billions of rupees? The idea is, it is the geology which makes it. The idea is, we will discover today that there are three basic factors that we are going to try to address today. Although it is not the only three factors, there are many other factors. But three factors are the most contributing to it. One is called the structural geometry of rocks, because the rocks are bedded, blocky, jointed, faulted, sheared and cleaved. So these rocks will contain such type of features, and these factors will actually be most contributing to the sudden failure of the rocks. And slopes will be in fact made up of those rocks. So when the slopes will fail, the rocks will be in fact devastated. So idea is, now just observe this simple diagram. The slope is having a steepness and there is a failure plane which is cutting the slope. Did you understand? The failure plane's dip is less than the dip of the slope. When it happens like this, then this side is open. So the rock mass can simply slide down the plane and come out on the other side. Are you getting it what I am saying? So we have a slope and we have a slope of this. If the slope of the failure plane is gentler than the dip of the slope itself, then the block which is in the hanging wall or the upper line above this failure plane can simply comfortably come out because it is daylighting outside in the open space. This is called a plane failure. So this failure is one type of a structural geometry that leads to a failure. You can see a plane on the roadside which has already failed and the whole material has been carried away and the large planes are basically exposed. Now this is one example where a partial plane failure enclose a wedge-like material in between. So when there is a failure, when the two joint planes intersect along the line of inclination, the block which is actually held within will simply be transported along that line. This is what is called a wedge failure. So this is another structural geometry. So this wedge failure will form, and then you will be able to see that the wedge will actually have a form. So there are examples like this, and you can see that wedges have formed and the material has failed and the wedges are just lying just like them, just to give a proof that wedge failure has happened. Next thing is, there are large wedge failures. You can see this. Now, another way that we can see that a failure can take place is that the slope will dip this side. On this side is the road, and this is the cut slope. The rocks will dip inside. That means it is inside the slope the rocks are dipping in that direction. When the rocks are dipping in this direction, part of the rocks are overhanging the slope, so they may fall down. This is called toppling failure, and this is another structural geometry that might happen. In the figure you can see that rock beds are trying to topple down because they are dipping inside the slope, and when the whole material falls down, it will be a topple. And this is what exactly a toppling will look like. And the toppling has started initially now you are driving and suddenly it falls down because it just gets out of strength. Now, the third and the fourth structural geometry is called a circular failure. Means you are going to see that the whole materials which are falling down, they are bounded by a circular surface, and the circular surface is encircling and encompassing a material inside them, including rock, soils and soft material, which are all actually having very loose materials, suddenly just tossed down like this. So this is called a circular failure. The natural example is there already, and you can see that how circular failures on the roadside have taken place. So large circular materials will be in fact along the circular arc, mass failure will take place, and the roads will generally get devastated. So then this is one of the road already constructed, and then the circular failure has eaten away part of the road away totally. The person who drives from the other end suddenly is caught by a surprise. Where has the road gone? The entire material is no more there. The other end, then the road is basically coming. So circular failures are very talented. Now the question is this: if such type of things happen, then how to design a road? The first thing that comes to all of your minds are, we have to predict. We have to predict when this failure will happen. Now there are two ways of prediction. A failure that will take place will have two different types of prediction. One prediction is, where will it happen? That means, along the road length, where is exactly those places where the rocks are more likely to fail. The second prediction is, when will it happen? That means, at what time, minutes, hours, seconds, we'll be able to see that the roads will suddenly start getting affected by failures. And then we will be seeing that. So one is called a spatial prediction, another is called a temporal prediction, means space and time. Where it will fail and when will it fail. This talk will address, first of all, that when it will fail cannot be answered if you don't know where will it fail. Because when I understand where it is failing, then the second subsequent question comes, okay, you are saying that these are the places where failure is basically most likely. Now tell me when will it fail. So the second step will be to find out the time. So for that time there are different methods that we employ, but where will it fail is the most important question that a geologist must answer, and this will be in fact how to do that, how to predict this, and what all we have to actually do in order to understand that basically to how it is going to happen. So I will give you an example of a case study that I have done this, and this is a work which has recently been published in a very good journal. This work endorses and develops a safety and a very strong prediction of a highway that is going from Tukadoji to Plenary, and this geological map shows that the Tukadoji road is along that blue line. From the backbench are you able to see it? All of you? Can you see the blue river? So this river is the Bhagirathi river. The road goes parallel with the river. That means if something happens on the road, the whole jeep will roll down and fall into the Bhagirathi. That's it. And the other end is a very high steep ground, as you have already seen. Now this is the geological map, and you can see that from the left side, which is written as Baretti, the lower corner, this is called the bend, which is called the Tarasu bend. From there, two roads actually go. One goes to Gangotri along that Bhagirathi river, and another road goes to Jamunatri. So two roads, this is the Jamunatri Gangotri divide, and they flow through, and the roads are constructed for multiple rock types. You can see that the geological map shows different colors of different rock types. There are different formations. Rock types are mostly schists, phyllites, quartzites, and limestones, and fencing volcanics, and metavolcanics, basic volcanics. So these stuff are being cut across, and the road has been constructed. Now, when I say the road has been constructed, what will you actually think about? That excavator must have been staying there and has been dragging like this. That was also employed. But when the rocks are too hard, when the excavator cannot come out, then what the people and the contractors do you know? They will put detonators inside and they will make a road blast. So when the blasting takes place, materials actually are basically excavated so they can remove this material. The idea is this, that this blasting causes a severe vibration inside the rocks. They do not actually show the effect of these vibrations. Later on you will see that there will be a lot of landslides happening. Say for example, I'll give you a time analysis of 4 years of photograph of this same. Observe that in 2010, the same road does not have to get landslides in the same. This white patch of landslides are developing. There was no landslide at all. Then in 2013, additional landslides were also basically starting to promote on the already happened landslides and get modified. And with this, new landslides also have started developing here, which was not actually there earlier. And in 2019, you see what has happened is the entire road has been covered with landslides. Here and there, everywhere is basically coming. Imagine what is basically going to happen for the vehicles that are basically moving. Now this is the time when I entered into the scene and started to study all those structures and understand why they in fact characterize the rock mass and tell that whether it's a good one or a bad one. So this is like giving marks to a particular parameter. I see a rock, I see a fracture inside. Okay, if it is containing only one fracture, I will give 8 out of 10. But if it contains 10 fractures, I will give 2 out of 10 because the rock definitely is weaker than the earlier one which was containing only one fracture. Are you getting my point? So this is called a statistical marks giving or a weightage evaluation. So this has been done. Otherwise, you don't know which part of the rock gets how much marks. Accordingly, you will classify this as a part of it. They will not have any failure. These sectors have very bad quality, so they will be having a failure. So now, we will straight away go to see that this is the area and the photographs that you have seen from the satellites. They are the real field failures. In fact, I would like to tell you that I was basically trapped within this failure that has happened. My vehicle just crossed and the failure happened. And it could have been just a nick point. I would have not been able to stand in front of you and listen and talk and interact with all of you. The idea is landslides can be vigorous. You can observe that the vehicles are still standing behind. So now the failure has happened. It has to be cleared off, and the road has to be actually made into a large clearance so that things has to be actually done. Now observe that this slope and the rocks which are basically taking inside, the trees are vertical. Observe that this tree is not vertical. It is rotating continuously towards the road, and it is rotating at a very slow rate. You cannot observe it is rotating. So after 2 days you come, it has rotated more. That means internally it is failing. And what is happening to this truck, the bus doesn't know about this story because it is coming from a far distance. So just imagine if the bus moves and then the whole situation falls down. We will have a devastation. So this is the idea is that these are all and a part of failures. This is a circular failure you can see, and this is a bus and it is a truck. So see the size of the failure. It's a very large area, and the area has started taking fail around circular arcs. There are large failures of those that are taking place, and this is the road level. The road is basically this level on which the vehicles are moving. And well, what is this level? This level is the river Bhagirathi. That is the Bhagirathi river. So So the river level is basically much down, and this is exactly the already reported failures that we have in this case. Now, coming to field orientation data generations, I will just don't go into the complexities of the data sets. Just understand that they are the parameters that we have to collect data from the field. We have to collect this. We have to stand on the outcrop, measure all this data, write down in the notebook, and then organize it in the form of a table. So 12 locations we have collected data sets, and then we characterize the area, structure, mythology, and all its internal discontinuity planes that we have. And this is what exactly the things will do, and we will make a structural geometrical analysis. So this will in fact give us which sector will give a wedge failure, which sector will give a toppling failure, and which sector will give a plane failure. There can be more than one type of failures in one section itself. So we can have a combination also. Now these combinations are basically listed out in these 12 locations after the data is analyzed. And this is called the stereographic projection and stereographic analysis of the data sets that we do. Then find out, in this case, that these are the areas that we find out to be more vulnerable to failure. Although there is no failure at this present moment, but some proof shows that these areas have already undergone a plane failure. As per our analysis, part of planes can be exposed. You can see that they are actually dipping towards this side, so there is a toppling failure chances also. So plane failure and toppling failure both are basically present in this location L7. And like this, there are many wedge failures are basically in L4, L11, and there are wedge failures that are basically awaiting to come down, and they are again toppling failures which are basically threatening the truck which is basically moving on. Every time a truck moves, every time there is a vibration, and the material is just waiting to fall. So a large block falls, we have fallen. So the idea is that we have a systemized way of analysis. So now what we do is we rate the rock mass and give marks. So marks are given on the basis of these parameters. Joint spacing, that means how fractures are spaced inside the rock. Then RQD, rock quality designation, it's a parameter of engineering. And then we have a universal compressive strength. How much is this rock? What is the amount of pressure that the rock can bear before it fails? So that is called a uniaxial compressive strength. We have a joint condition, whether water is percolating through the joint or is it weathered all about. And finally the groundwater, whether the joints are basically having water containing within it and water is basically flowing through the joints, that we will be able to understand. So these are the basic parameters on which every location will be evaluated and marks has to be given. How much marks we give? So for example, if it is more than 250 megapascal for the MCS, we give 20 marks. If it is 1 to 5 megapascal, we give 3 marks. Very simple. That means it's very weak. Like this, for all the parameters that we will give, and we will add up at the end to say what is the rock mass marks that actually that particular location gets, and that is called rock mass rating or a basic rock mass rating for this. Okay. Now, this rock mass rating will in fact actually give us the ideas that how this is basically going to give us. So this is the rock mass rating that we have carried out in those 12 locations, and we have this particular values that gives us the different, you can yourself categorize what are the good rocks and the bad rocks there. Then finally, we have a slope mass rating also, and how the slopes are basically mass rated, that also we characterize, and then we find out this is basically the slope mass rating characterization. Some slopes are basically very poor. Say for example, we have values of 29.30 degrees in L7, which is giving us very bad quality rock mass. That means there is an eventual chance of getting it failed. Now, when I plot this with the probability of failure, we see that they are basically having the highest probability are found in these locations, these 2 locations, and they are the very important areas where we must understand that the roads have to be guarded. Now, there are other mechanisms of getting it solved and understand how the different another slope mass classification is Q slope mass. This gives us the idea about the slope that should have been there cut by the Komatsu excavator. If it is less than that, then it is good. If it is more than that, it is unsafe. So when the slopes are basically plotted, that these slopes are unstable very much and some of them are obviously stable. So the idea is that this particular mass characterization of the rocks are very essential to realize that what are those characteristics of those locations. Finally, we have a hazard index parameter which says that how weathered or how affected those rocks are by the rain, by the ice, by the glacier, because it's in the Himalayan regions. So they have certain points to say here, and we will be able to see that these are the basically hazard index rated scopes, and they are having this sort of a characterization. So that means we can have many of them are having very poor. So there are now using all these, we develop a new concept of a net where we plot those locations taking two of these classification parameters at a time and then say which are slopes which are severely failed, which are severely unstable, or which are unstable and which are not stable. This is one of the predictions that we have made. So with this, since the time is short, I would like to conclude that with this particular case, we have to have this particular Varaso highway. Then what we do is we simply locate those points by using this slope mass classifications, the structural geometry, and obviously some clay minerals which actually induce a failure within the rocks. And those combinations will ultimately lead to exact steady prediction of slope failures in those areas. And then we will be very careful to see either to make a road divert or we construct special things in order to prevent that slope. And this is what exactly that will form. This work is actually drawn from this journal, and this is something which will be in fact giving us the highlights. If you are interested, you can log into this and read it for yourself to understand how it is done. So finally, this is a classic example of a slope failure inside the large highways that has taken away the highways altogether. So what we understand is this, from this, that safe transport design will require an integration of these three parameters. And when we do this, we actually find that the roads are well designed, protected, and more meaningfully constructed without much loss of life and money. Thank you very much.
And other things. One of them was the Plenary award, and you have heard the lecture by Rashtrasant Tukadoji. You must know that Plenary award has been distributed once the Indian Science Congress completed 75 years of its existence. Now it is 130-year-old organization, much before independence. So another important thing is Young Scientist Award. So I would like to request just know that all the three people, Mr. Tukadoji, Mr. Mohammad Asif, and Mr. Ashutosh Pandey, all three of them occupy the seat in the front. So dear friends and dear members present here, you all know that this Young Scientist Award presentations is one of the very important component of Indian Science Congress, and especially of the Earth System Science section, where the various abstracts have been sought, and after a very thorough evaluation of the abstracts, only three young scientists have been chosen to make their presentations. So for this, we are going to evaluate this, and you know that the time allotted to you is 10 minutes only. So after completion of your 8 minutes, you will be just indicated. If you take longer time, your marks gets reduced. If you finish too early, that too is not considered to be good. But as it is a competition, competition, so you all are supposed to complete it. One of you will be leading the elementary program, you will be getting a recognition through the chief guest of the elementary program on 7th. So with this, start the presentations for getting the Young Scientist Award. So the first one is Mr. Rashtrasant Tukadoji. He is from Indian Institute of Technology, ISM, Dhanbad.
I did my PhD from IIT Dhanbad and Rashtrasant Tukadoji Maharaj Nagpur and did my PhD in IIT Bombay and the supervision of Professor Rashtrasant. Today I am going to discuss about elaboration of QLI in Actor Studies for second unit of India. The study area is the Rangit window of the second unit of aspects. Also, I compare the data obtained from the core samples from this Rangit window with the undisturbed essence of radical change area to have a view, have a comparative view of the microstructure of the organic matter and the mineral matter changes or transforms with increasing gravity. So the tools I employed was the micrometrography, the proximal atom analysis, Raman spectroscopy, FTIR, XPS, GOCTN, stabilizers, and etc. So I will just give a glimpse that with increasing cold rank, the non-astrobic vitrinite transforms into strongly anisotrophic vitrinite in anthracite. And the maximum reflectance values increases from 0.58 to 5.94. So these reflectance values indicates anthracite area and the closer association of intermediate reflectance axis with major or the maximum reflectance axis indicates biaxial negative vitrinite reflectance property. These are mainly found in the tectonically deformed region. So you can see the coordinate is strongly homogeneous anisotropy. It transforms from white to black if you rotate the polarizer from 0 to 45 degree. But the surface line you can see they show net line or wavy anisotropy when you rotate the polarizer. Also, the relation between bireflectance and harmax indicates the anthracites or the whole samples from the second unit forecast belts are at the onset of pre-graphite condition. So Raman spectroscopy shows these strong changes in microstructure from luminous anthracite with depletion of S-band. Look, there is no S-band in anthracite, but there is S-band in luminous. Strong depletion of D4 band, almost 1/4 of D1. Depletion and the enhancement of D1 band is yellow mark. And the depletion of G band. So these changes indicate anti-dual metamorphism at the anthracite level. At the peak metamorphic temperature we estimated varying between 325 to 380 degrees Celsius, close to gaseous phases. And you can clearly note there is a major changes in QLI structure that I will discuss about. That these two are the outer surface superficial unification of QLI. But the red one is the inner surface hydroxyl stretching. So, but these superficial stretching gets depleted with increasing cold rank due to dehydroxylation or another process that we are telling about metasomatism to enlarge. And but this the internal hydroxyl stretching is getting preserved due to strong hydrogen bond energy. So if we come that I told about the metasomatic changes, how I infer that? I infer that from the clavicular composition. You see the K2 of the air-to-H ratio and index of composition radiation. You can see in between the flow samples it contains non-molinite, ferrocite, kaolinite, but it transforms to light with increasing cold rank. So both organic and inorganic materials are getting transformed with increasing cold rank. Now, if you plot the samples AC and the diagram, you can see the between the flow samples, the plain colors are mainly dominated by cement here that I discussed this slide before, we are getting this mononuclear stretching or the mononuclear stretching peak OHP in the bituminous structure, but and also mononuclear OH bending. But the Eli stretching, this one, Eli stretching in anthracite, this stretching is not present in bituminous structure. So it is additional confirmation of keolinization of dilatation of keolinite. Normally, evaporation takes place at 410 degrees Celsius with reaction of ammonium with the keolinite to form ammonium elite. But as we saw that the temperature is less than 400 degrees Celsius, the metazoic changes was a bonding way to form this elite. So the keolinite by quartz content it decreases from bituminous to anthracite. Means the keolinite content is decreasing. Also, the total intensity of keolinite and total intensity of quartz feldspar obtained from this FT gap peak fitting is also decreasing with increase from bituminous to anthracite. So, additional view that not only this spectral ratio, another ratio I am telling about that. This K2/A2, you can see this, the K2/A2 ratio. It also indicates the amount of potassium metazoitism. In bituminous it ranges between 6.36 to 15, but in the anthracite it ranges between 29.80 to 80.13. You can see how much intense for the metazoitism in anthracite samples. So we infer that the technology, Himalayan technology, will have surface secondary structures in anthracite coals through which the metamorphic flow is inhibited, the potassium which metamorphic flow is inhibited, and transform the keolinite to elite. So, coming to conclusions, the Esenga pouch suggests dilatation of keolinite in anthracite samples, which is supported by CA and PIA, and the high K2/A2 ratio in anthracite partner supports dilatation. And the spectral presence of Eli stretching in anthracite and mononuclear stretching in bituminous may further imply the transformations of keolinite to elite with increasing coal rate. So I am deeply indebted to my supervisor, Tukadoji Maharaj Nagpur, and HOD and all the dignitaries, and Professor Tony Sturdy for operation finishing. These are my publications. I published got articles in 5 first version journals. Thank you very much for your kind attention. Sorry? Yeah. The reason that the anthracite were affected by the Himalayan technology. So we hypothesized that it created some secondary fractures in the coal samples that we found in Raman spectroscopy as well. You can see few particles. So you can see this green band here, this litchi band. These are the result of that deformation of that structural defects. So there are metamorphic fluids, potassium metamorphic fluids would have been inhibited through this way and altered the keolinite to elite.
What is the age of the molten salt?
So it was after the Permian, because the post samples are of Permian age.
What is the Indian representative related?
I do not correlate in Indian distribution with these samples, but we hypothesized that because we did not find direct evidence of Indian alterations. Because if we found that the coal samples, the vessels were charred, but we found a fresh vessels.
Thank you, Mr. Doshi. So it was a good insight. So now I would like to request Mohammad Asif from Indian Institute of Technology, Dhanbad.
Good afternoon, respected person of the dais and my dear colleagues and my dear delegates. Good afternoon to all of you. I am Dr. Mohammad Asif. I have done my PhD from IIT ISM Dhanbad under the guidance of Professor B.C. Panikati and Professor K. Kawaja. Right now I am working as a postdoc research scientist in the School of sequestration, and I will talk about the sample collection and characterization, and indirect measurement of coal wet gas content, and stable isotope using the INS modeling, and competitive absorption using the IST modeling, and ECBM displacement using the three approaches: dispersion, diffusion, and competitive absorption, and the conclusion. These are my gist of my PhD journal thesis that I am going to present. So, after the industrialization that happened in Great Britain at 1752 and 1840, it has brought many challenges. The main challenge is the increase of anthropogenic CO2 because of the human activities. This happened between 1752 and 1840. This has due to global warming, what happened, the greenhouse gases, though greenhouse effect is good for growing vegetables and all, but if it has to increase up to optimum level, it has brought many challenges, like it takes the CO2, if CO2 increase in the atmosphere above some level, then it will trap the heat but does not emit it. So the atmosphere gets get heat up. So due to that, it was predicted by International Panel of Climate Change that after pre-industrial time, it was increase of 1 degree centigrade. This 1 degree centigrade, and it will be around 1.5 degree centigrade between 2030 to 2052, and it has been increased from pre-industrial time up to 130 ppm, from 280 ppm to 420 ppm. Though we see that there is an increase of only 1 or 1.5 ppm, but at the global level it is more. We see that the very less compared, but at the global level it is very more. Like it is some CO2 emission of 4 countries has been shown in this diagram. China has been risen up to this level. USA has come down, but India has surpassed Russia. At 1961 it was around 1.32%, but after 2014 it has been increased to 6.54%. So, in order to control this CO2 emission, there are 4 methods have been suggested. Like I will be speaking use of less carbon concentrated fuel, using energy efficient methodology, increasing conservation, and CO2 sequestration. I will be speaking of the CO2 sequestration. CO2 sequestration geological storage is one of the ideal method to combat the CO2 emission. Like I will be speaking of how to store a CO2 in unminable coal seam. My topic is that I will be speaking of there are various methods, like we can store in deep saline aquifer, depleted reservoir, oil production, natural gas reservoir, even a saline aquifer, even in the sea we can also store. But I will be speaking about the unminable coal seam only. What is CO2 ECBM recovery? What happens when CO2 has a greater affinity towards coal? When we sequestrate CO2 in coal seam, it has a greater affinity. That's why it displaces the methane, and CO2 get absorbed in place of methane. So methane recovery get enhanced, and moreover we are omitting the CO2 also from the atmosphere, and the cost of sequestration can be offset by enhanced coal methane recovery. Yeah, this is a diagram to show the CO2 ECBM process. In order to combine CO2 sequestration and enhanced coal methane recovery is also called CO2 ECBM process. One is injection well, this is injection well, this is production. We are injecting CO2. CO2 has more absorption capacity, so it will get absorbed. Methane will come from there. I am saying CO2 has higher absorption capacity. What will be the reason? There are 4 reasons I have identified that due to absorption due to the physical absorption is there. It happens due to only van der Waals forces. So van der Waals equation in under production from the India. I've just shown like this India has been India only. Scenario of the world, first ECBM well was built in 1995 with Sanjuan machine that is in USA, and some came from Canada and Japan, Quincy also from China, and CO2 emission from the India mainly comes from the power and steel plant, which is around 72% of total emission. And though we have started CO2 sequestration project, but this CBM field that I have shown earlier slide, it can be used for the storing intravoluntary CO2. Sample collection and characterization have collected source sample from the novel borehole from the Jarepur field, and I have characterized on the basis of the approximate element and petrographic analysis that I am not showing in this slide. On the basis of ASTM classification of rank and stage code chart, I have found the rank which is characterized on the basis of MICP experiment and PIA, core image analysis. Core image analysis is a new novel thing that I have done in my thesis. Less than 2 nanometer, if according to IPAC classification, if there is a less than 2 nanometer, there is a macropore. If the size is 50 nanometer, there is a mesopore. If greater than 50 nanometer, it is macropore. Mainly I found the MICP is giving the minimum diameter of 5.3 and 5.2 nanometer. These are MICP classification. It is done by using the Wasserman equation, which is this 108.1 P in PSI. Yeah, this is the new thing I have done in my thesis, that I have taken the same images and I have segmented with images software. The black part here, the black parts are core and white parts are the pole. A dash is the pole and B dash is the core. Gas content of there are very few indirect measurement of coal bed gas content, like basically in USA and China, and India. No one has done for the indirect measurement of coal bed gas content. I have done using the approximate analysis. I found this equation, and based on this equation, these are the nothing but the approximate parameters. I found the gas content is that for these two boron sample is found by 8.73 and 10.1 around 10 cc gram. Stable isotope I have done by I have done stable isotope analysis. Stable isotope analysis has been done because of stable isotope analysis done because of to know whether it's microbial, whether it is biogenic method or thermogenic method. If it's the biogenic method, we can do microbial enhanced method production. If it's the thermogenic method, we can do CO2 speed production. These are composition and stable isotope analysis. The computed option I found using the IST modeling. When we sequestrate CO2, there is a composition of absorption side between CO2 and CO4 that I found using the IST modeling. The multi-component isothermal, and these are co-absorption isothermal I found at the supercritical condition, that is 1070 psi or 7.38 megaparsec, and these are CO2 displacement process, which is necessary how CO2 is displacing methane. The breakthrough analysis to know whether at what time the CO2 will break through in the production mill. And these are breakthrough curve. If there is a 2 to 3% of CO2 in a production mill, then it's called a breakthrough time. Termination time, when we terminate our process, when there are 100% of CO2 in effluent. So conclusion is that my research is properly segmented with the 70 SDG goals of United Nations, which is the I have written here, which is the goal number 7 is to use the cleaner energy, and goal number 13 is to climate action. my research is focused on both. I use the Illinois energy and the climate action. I am completing CO2. Thank you very much. These are some of the references I have covered. Thank you very much. If you have any question, yeah.
Which coalfield you prefer?
Jariapur. Because there is a novel drilling was going on. Simple was going on now.
But association of this, coalfield region, where do you find more? Where will be the volume will be higher?
Actually, I focus on the because I
Lignite one?
no, I tried because mainly the coalbed methane process occur in a low volatile to medium volatile thickness.
Thank you.
If you have any question.
And to take a case study, I selected new architects already seen pattern. Now, just for the introduction, as a geologist, we know that the Earth's mantle is peridotic in nature. That's what you will find in all the textbooks of petrology. But let me tell you, for the last 2 decades, this concept has been changed. And what we now know, that Earth's mantle is not only peridotic, rather it's extremely heterogeneous. So when I say peridotic, what I mean a rock which is composed mostly of olivine as well as pyroxene. And when I say pyroxene, it means a rock which is dominantly consisting of pyroxenite. So now what we know is that the Earth's mantle is extremely heterogeneous, and it's visualized that it looks like a marble cake. So a marble cake, you can see that it's a mixture of 2 and more components. So we can consider one component as pyrotic and one component as a mafic lithology, which could be pyroxenite, which could be basalt or something like that, or even magmatite. But how do we know the source lithology of basalts? Since now it has been proven that mostly pyroxenites play a crucial role in the origin of basalts. Particularly, if I have to give you an example, I'll give the example of Hawaiian basalts in Pacific Ocean. And we know this from the mineralogy of the basalts, we know this from the geochemistry of the basalts, and we know this from experimental petrology. So these are some famous studies that has proven these things. So the question that arises, which I am going to discuss and which I have addressed in this paper, is whether such olivine-deprived mafic lithologies were also dominant lithological heterogeneity in a relatively hotter Archean upper mantle. Because we know the present-day basalts are generated from pyroxenitic mantle, but is this applicable to the Archean pattern? So let us see this one. To address this problem, we need to understand, we need to sample Archean basalts, which we can find only in the greenstone wells of the Archean patterns. And as a case study, I have selected Eastern Harbor pattern as an example. So these are different curvilinear systems of the Eastern Harbor pattern, and most of these are, in fact, all of these are 2.7 to 2.5 GA Neo-Archean in the age. And these are the data sources that I have compiled from the literature, geochemical data sources. And as you can see, just let us see the characterization of these basalts. We have 2 groups of basalts. The first one is alkali basalts, as you can see here, and the other group is subalkaline basalts. And if I have to name them, I'll call them colitic basalts. And you can see here also, most of the data deployed in the field of colitic rocks or either in the field of transitional. Transitional means colitic to calculate as transitional, but they are subalkaline basalts. So this is what we conclude from these 2 trace elements diagram. These are mafic volcanic rocks of the systems of the Eastern Harbor pattern. They are colitic in affinity, and some of them are, of course, for example, from Peninsula system, alkali basalts. And these are the average geochemical data which is plotted from all the systems. And what is we all going to see here is conspicuous negative activity at niobium, at zirconium, hafnium, as well as titanium. Now these geochemical traits are signature of subduction related magma or from the rocks which have undergone crustal contamination. Now let us see how we are going to distinguish between these 2. So we know that continental crust is mostly rich in granite or granodiorite. So granite or granodiorite material is rich in zirconium and hafnium. So if we have crustal contamination, the zirconium and hafnium value should shoot up, not we should expect any depression. So if we have these characters, we mean that these conspicuous negative high field strength elements anomalies is a hallmark of geochemical trait of arc related basalts which we are observing here. And again, the alkaline basalts of the peninsulas is belt shown here by this broken line, shows similarity to the ocean island basalts. So we are covering a spectrum of diverse basalts of Neo-Archean pH. This is the. Now let us use some trace element ratios. So why these ratios have been used? Just simple analogy. They are like just two friends. They always try to be together. So if I have plotted iron by ytterbium and zirconium by yttrium here. The reason is that they behave similarly in mental melting. So their ratio will remain constant irrespective of different degree of mental melting as well as crystal fractionation. So that's why I say that they are like friends and they will remain together. So their ratio remains almost constant. And the same can be applied to this plot as well. And we can see here that the mental sources for these basalts is extremely heterogeneous. The enrichment in the mental source is due to recycled component and as well as a depleted component. So that's why these basalts are very apt for this study. Now let us look at what are the mental source lithology. So to know the mental source lithology, from experimental results, Young and Zhou, they compiled more than 600 and 700 experimental results and they created discrimination diagrams based on major oxide function, and that function is called as FC3MS. And FC3MS, as you can see, the higher is the FC3MS value, it means it is derived from a phylogenetic mental source. And we can see that dominantly the data from with MgO more than 7%, they lie in the field of higher FC3MS value. Now you can think why I have taken MgO more than 7%, because they represent the almost primary composition. I won't say that they are exactly primary, they are almost primary composition. And MgO more than 7% means there is a very less role of crystal fractionation in these rocks. Now, from these two discrimination clauses, I can say that these are there is a dominant role of pyroxenides in their mental source. Now, let us look at some more complicated function, and this is FCK and TMS. And as you can see, it is a very complicated equation which uses all kinds of major oxides in them. And using this function, also we can see that the data with more than MgO 7%, they are showing a mixed periodic and pyroxenic character. And this is proof from this diagram. This is a representation of basalt tetrahedron. So you have a triangle, CS hermatite, phosphorite and quartz on one base. It's a triangular base and we are projecting it from that side. So it's like a tetrahedron, and when we project it and we compare it with the experimental bends, their values, and you can see that most of the qualitative samples, forget about these ones are alkaline stuff, we'll come to it a bit later. So all these qualitative basalts, they plot towards the field of silica saturated basalt, which means that there is a crucial role of pyroxenides in their mental source. And as you can see, they are comparable to the hybrid partial bends of eclogite peridotite reaction. So as I mentioned that they are carrying signatures of arc-related basalt, and if you see eclogite peridotite reaction, when a subducting slab goes inside the mantle, the slab metamorphoses to eclogite facies, it will release some fluids, that fluids will react with your peridotite, and since the subducting slab is an oceanic crust, it has sediments also, that siliceous melt will react with peridotite to form pyroxenides. So this is why we are finding that pyroxenides are playing a crucial role in their genesis of this qualitative basalt. Unlike the alkaline basalts, which are mostly silica undersaturated and they pack a deeper portion of the mantle, which is what we say that this is mostly peridotic. So the shallower mantle is again a mixture of peridotite and pyroxenite, whereas the deeper mantle remain peridotic. So this is the conclusion. So the question that we wanted to address was whether we have the pyroxenitic where dominant resource mantle lithology heterogeneity in Archean mantle, and the answer is yes, they were a dominant source of lithological heterogeneity in the Archean upper mantle. And this can be, this work can be extended to encompassing all the greenstone belts of the world, or we can take a large data set of all types of Archean basalt and we can apply this work to a huge data set to conclude this thing in a better way. So I would like to thank the head of the Department of Earth Science and the Dean of the School of Physical, Chemical and Applied Sciences of Pondicherry University for extending their help. And this is the place where this work was carried out. And of course, my PhD supervisor, Professor Rashtrasant Tukadoji Maharaj, who introduced me to this beautiful world of quantum
for development.
No, sir. If the age of the basalt is 2.5 G, if the age of basalt is 2.5 G, it means it was derived from the metal.
Our nature series, hardly you are in the top 2 levels, not downward. Things are there.
Yes, sir.
Yeah, this is important observation. If it is before even 1.8,
Yes, sir.
also this during that time subduction was common.
Yeah, definitely. Definitely.
So subduction between which plates?
So we cannot name the plates there because there were many plates that have come to this planet, they have subducted and they have joined together. But this is
minded. Plate tectonic in Archaeology what time?
sort of
Same thing I was.
It's all right.
Cannot say.
Yeah, it's all right. So thank you very much.
This we have. Is there anyone else also present there for?
I'm grateful for the lack of knowledge about it, or maybe because you don't have much information about it. So if you go into a quick search from Google, you'll find some a very basic knowledge of water correlation will come into the picture. If you go into details, you'll find that the first law of geography is like near things are more related to each other than distance things. So if you see the person sitting next to you have similar age, on the back also if you see the person sitting next to him is of similar age. But then the front seat and the back seat, they have distant to each other, so they don't have the same relationship. So that is true for any kind of data that we collect in geosciences. And spatial order correlation is a kind of quantifying that relationship in distance or direction. So it can be positive, it can be negative. So how do you identify and measure? So Morans I index or C index, they are common indexes, but the one which I am going to talk about is variogram modeling, where you model a variogram model. So Morans I index is very common in various fields. So Morans index, which is not. see the nitrogen data, you can see soil, phosphorus, potassium and pH data. So you can see some with direction and with distance, they are related to each other. They are not simply, say, unrelated. If you see a income quality, where you are born, where do you study and where do you work, has a relationship with your income. So it is not, so even in economics data you can see that some things are more related to each other than the distant ones. If you are, say, born and brought up in Bangalore here, your income might be higher compared to living in another region. So this is a very important Lisa analysis where you do this kind of analysis. I will not go into details of this. But suppose you talk about the groundwater data. Groundwater data, we know that groundwater level follow the topography, or the quality may also be linked to the nearby regions. But what we have seen is that groundwater data also has a very specific and strong directional component. Means in one direction you can find similar values up to 500 km. In one direction 500 km and the orthogonal direction 90 degree to each, you will find only up to 80 km. So in one direction things are related up to 80 degree, then it changes. And then in one direction it is 500 km. What it means, the underlying geology or the deposition might be having an effect on that. So if you see the overall structure of this Himalayan range, so you have a Ganga more or less going east-west. So east-west we see a much higher correlation up to 500 km and say north-south we say only up to 80 km. So and the angle that you see over here is more northwest and it is more east-west over here. That is also visible in the analysis part. So if we talk about the Punjab region, these are the dots where we have the CDWB ground data, groundwater level data. So our say main objective is to find out the directional nature of groundwater level with distance and with direction. So these are the simple statistics. Now here it does not have to be any bearing on say directional nature, but it is simple statistics. But one can make diagram maps. If you see those diagram maps, this is north, east, south and west, and you see a red color zone running there like this. So you have relationship in one direction, a very strong one, and then a completely opposite relationship in orthogonal to that direction. And if you construct another one in between, you see a middle and mid-level relationship. So if you talk about the paragraph model here, you see in one direction you have this much range, in other direction you have different range, and in the between direction you have the graph in between. So groundwater has a very strong directional nature. So it is not isotropic in nature. Groundwater level is not isotropic. It means if I am over here, I may get the same water level in 500 km same height. But if I go in this direction, it may be changing at a much faster rate. So the same we have done for say multiple seasons. And if you do the bias analysis, you can see that if you do the directional modeling, the bias is only +2 and -2 meters. But without that directional component, it can be 4 or plus or 4 minus meters. So it means if you take the directional component to your model, your accuracy is much more higher to predict the water level depth. So it is not only about water level depth, even the water quality varies in the same direction. Means in one direction water quality will be very high to a very long distance, and in another direction the water quality will be degrading at a much faster rate. So even without going to the field, if you do this analysis, you have a fair idea about what you are going to get in the ground. So we have done this modeling with different models, and we have seen that this directional kriging is much more relevant and has much more say statistical model validation statistics compared to other models. So this is one of the best models to make a water level map or a water quality map. And the same for Bihar, you can again see that this directional kriging has much more better maps compared to normal inverse distance weighted method or the polynomial method. So the same data set which we used to have only simpler methods earlier can be done at a much faster rate, because nowadays you have modern equipment, modern sophisticated softwares that can do the same job in nearly the same amount of time. But the results that you get are much more accurate in nature. So what it simply means, the paragraph modeling or paragraph map helps in prediction of anisotropy in direction as well as distance, and you can quantify those for specific regions, and you can get much better results compared to say a normal traditional method. So So and this can be applied not only in groundwater but in water modeling or in any special data you can do. So with that, I will thank the CDW for providing the groundwater data for us, and thank you for your kind attention.
Get the CO2 available from the different sources like from power plant, gasification industry, and also from coal industry and other related industries and other industries. So sources, and we are actually work for the capture process, but nobody has told us about the storage thing. So storage is very important for us also, because no work has done till for the storage, because capture is nothing without storage. If both has to come in hand, so storage is very important. So I am here going to present my work on mineral trapping basically, and the injected CO2 that will be that I will show in the slides, but the slides are not visible. First.
शुक्ला जी, हमारे जमाने में ऐसा था नहीं, बोली बोलना था।
So finally, sir is asking about what is ESG and this ECVM. ECVM is enhanced coal bed methane recovery. This is the methane stored in the coal beds in the coal, able to come because of they are at very low pressure and low permeability stage, and the gas content is very less. composition, heterogeneity, and this is the proximate analysis I have done for my sample, and I have shown for the coal sample and cell sample different histogram diagram, and also given the maximum and minimum and average constituents of proximate analysis that I obtained from the analysis. I have done this analysis at CSI at Simfer itself. This is also the other chemical constituents and elemental analysis where I have done this at CSI at Simfer lab and calculated for the coal and shell samples. This is a low pressure ambient solution. As the pores are very important because most of the methanes are absorbed at the pores and fractures and cleats associated in the pore. So we have to study the pores, and for that I have done the low pressure ambient solution as well, where I have calculated the surface area, pore size, pore volume, and other pore related studies. And according to IPC, there are four types of loops and 5 types of business loop and 4 types of structure. Most of the sample of my study area followed the cylindrical and type A type. This is the BT analysis. This is the BT analysis of my sample, and most of the sample I have already told that these are cylindrical, and BT surface area for only 6.787 meters square per gram. And similarly, the BGH and DFT plots, and most of the samples from BGH plot are mesosite 9.250 meters square per gram. And same the BGH and DFT plot, I have found that most of the pores are mesopores, and at DFT plot they are between 2 to 8 nanometers. This is the fractal FHS diagram. Here I have got 2 types of fractal dimension, D1 and D2, and D2 is mostly associated with the mesopores suitable for the sorption of CO2. This is the CH absorption and CO2 absorption. As I have already told that CO2 has 3 to 4 times more absorption capacity in coal, and this can be validated with this diagram. Like for your CH4, the absorption is up to 12, and here for CO2 it is up to 28. After injection there is a need to store the CO2. So by mineral trapping, there are 4 types of trapping we can do. The structural trapping, the stratigraphic trapping, residual trapping, and solubility as well as mineral trapping. But I am more focused on mineral trapping because it is the most permanent storage and there is leakage free. Because in this trapping, I will convert the injected CO2 into the carbonates, and this stable carbonates will never going to come in the atmosphere again and interact in the atmosphere and increase the CO2. These are some of the critical issues that I will face during my injection process, the groundwater sources, So the CO2 desorption. As the CO2 desorption comes, the shrinkage of coal and increases of aperture and productivity may causes very ground movement, and as is of economic and as well as engineering importance. So when CO2 swells the pores and decreases the aperture, injectivity increases and may cause the small ground movement. It is important for economic as well as engineering perspectives. This is the future work that I have proposed. This is the diagram of autoclave. It is a stainless steel material that I will keep the core here, coal and core sample, and inject the CO2, and from the gas vent valve I will connect it and study that how much CH4 can be obtained from the samples. And these are the after the mineralization process. As I have shown in the diagram, that mineralization process is slow process, but it is a permanent solution. So I will add some of the natural catalysts that are available in the scenario, and I will increase the process with this availability. These are the conclusions. The process of this research is to shed some of the light on the overview of the CO2 storage in the coal and sink and enhanced coal bed recovery in context of India and cell reservoirs, providing an in-depth examination and global potential of metric of CO2 storage and ACPM potential for Indian coal and cell gas. The deep unminable coal mines and reservoirs and associated cells are most suitable options according to my research, and with this ratio of 2:1 CO2 absorption capacity, the methane which supports in the CBM recovery. As a result, CO2 may be utilized to boost the recovery of methane, as well as it can be very cost effective and increase the methane production, and the problem of the CO2 storage will be solved. And the mineral different available in the different sources. There is a need to develop an integrated model for this process to continue. In India, I have estimated the CO2 storage potential is in the range of 10 gigaton of CO2 in unminable coal seam and cell. In India, the CBA potential is also between 0.3 to 5 gigaton of CO2. Thank you. Sorry, sir? Yes, sir. Maybe I have read by mistake. Cell reservoir or coal? Coal. Sir, I will already know that it will swell and swimmage the coal, but I will also, but then I will mix the CO2 with some of the other available gases like nitrogen. Yeah.
Thank you. I would like to discuss with you separately after this. Next paper is by Professor Pandey. He is on presenting.
Of a very heavy rainfall event which occurred in Delhi on 21st of May 2021, and the rainfall was 119 mm was recorded, and it submerged many vehicles, even big buses which run on the roads of Delhi. It got submerged, and that too it was late night and early in the morning. So many people got trapped. So what was the fact behind this was, like we all know what is a cyclone. A cyclone is basically a low pressure system that forms over sea. And the frequency of formation of cyclones is more in Bay of Bengal as compared to in Arabian Sea. But this particular cyclone, Taute, it was formed in the Arabian Sea. And what was the thing is, like all the cyclones have a basic characteristic. Like soon after it reaches the land, it should subside, it should dissipate or it should degenerate. After that, there should not be any kind of rain or any kind of system. It should dissipate, it should develop into a depression, and slowly it should move off. But this did not happen with the cyclone Taute. Soon after the landfall and the coast of Saurashtra, what happened was it weakened. But the next day, it got interacted with the western disturbance which was coming from the Mediterranean Sea. So this interaction of the remnants of the cyclone Taute with the western disturbance took this cyclone Taute from a tropical cyclone nature to an extratropical cyclone, and it intensified so much that it maintained a wind speed of around 280 kilometers per hour on the land. Uprooting of trees, damage to infrastructures, and torrential rainfall leads to European Center for Medium Range Weather Forecasting. And the flow chart, according to this flow chart, if the vertical wind speed at low levels is high, then it can be identified as a low level jet or as a bridge. It will be identified as a bridge to supply the moisture from the sea towards the land. And if this is done, then the necessary condition for the re-intensification of the cyclone will be satisfied, and even on the land, the remnants of the cyclone will be definitely, it will take a destructive nature. Then one more thing is, the winds, I have taken the ECM and WF wind at 300 HP, that is at upper level. And if at the upper level, like similarly like at the lower level, if at the upper level the winds are high, these upper level winds can even steer up the western disturbances or any disturbances coming from the northern parts of the India. And if these two interact, the cyclone that was remnant or it was weak, it can intensify into a very destructive type of a tropical cyclone. Then this is what we see here. Like for any cyclone to work, like to destroy something or to produce the heavy rainfall, it needs heat as well as moisture. As I've already mentioned that there was a low level jet which behaved like a bridge for the transfer of moisture from the sea towards the land. And along with this, there should be some kind of warm air. The warm air, if we see, it was slowly moving from the Bay of Bengal towards the northern parts or the northwestern parts of India. This is for 17th of May, and on 18th of May, if we see, this warm air is very close to this dissipating system. So it was basically fueling up the remnant of the cyclone Tauktae. And this is what we see here, is that the entire atmosphere was very humid over Delhi. So the two necessary ingredients for the intensification of a decaying cyclone have been satisfied. That is a humid environment and the supply of warmth for maintaining its intensity. Here we can see there is an upper level jet and a low level jet. The low level jet behaved like a bridge to bring the moisture from the sea towards the land, and the upper level jet, it behaved like a steer, like a wheel to steer the western disturbances towards India. Then what we see is, this is on 17th of May 2021. This particular cyclone was weakening, but later on 21st, it intensified into a thunderstorm type of a thing on 21st of May, and it produced a heavy rainfall. Thus, what we see is the factors are nothing but humidification and some amount of moisture or heat that we need, and produces us. Like what we need is an upper level jet, a low level jet. Low level jet will basically behave like a bridge to bring the moisture, and the upper level jet to steer the system that is coming from the Mediterranean Sea. And if this interaction takes place, what we have is nothing but an episode of Delhi, and even we can talk about the Uttarakhand flash floods. Uttarakhand flash floods, we say it's a cloudburst, but it was similar to this event where there was an interaction between the western disturbance and the particular local weather system. So with this I conclude. I thank the Department of Physics, Plenary Nagpur, as well as the Indian Science Congress for giving me an opportunity to present my paper here. And I thank all the delegates present here for their kind attention. Thanks a lot.
Thank you.
Yes, sir. Pardon, sir. Yes, sir. Sir, yes, sir. Like earlier we had cyclone like 28 years ago, which was of the same intensity. Like we don't have many cyclones over the Arabian Sea. More of the cyclones are formed over Bay of Bengal. But whenever they are formed, but now what we have seen is in recent 5 years, the temperature of Arabian Sea is rising at the rate of 1.5 degrees Celsius.
So this is an interesting study.
Yes, sir.
Correlate with the past cyclone patterns
Yes,
also
sir.
through the sediment records of the oceans or the terrestrial records.
Yes, sir.
So then it will be more interesting.
and geomatics techniques. So these are the aims. The aim of the Plenary is to assess morphologic characteristics using advanced RS and AR technology, compute basic morphologic characters, extract and delineate real morphologic matrices, that is linear, aerial and relief aspects from the subject topographics, analyze linear, aerial, relief aspects of the area, and to understand adverse conditions of the area and sustainable management of hydrological resources. This is the location of the area, and it is covered by the topographic 55G/7, 54G/10, 55G/11. The total area is approximately 250 square meters, and area ranges from 340 meters to 750 meters. These are the various softwares. First, we have the portable map, that is topographics of Survey of India, with scale wise to 2000. Then extra DM map, then IRS D3 Central Imagery, and ArcGIS 10.3 software. Now this is a flow chart. How we have come to the various aspects: spatial data, topographics, satellite DM, then neutralization, location maps, and then lastly morphologic analysis, linear, aerial, and relief aspects. Now this is the result and discussions. The present study incorporates, as I have said, that remote sensing and GIS techniques are used. This is the data which has been prepared by using the GIS techniques, and it shows fifth order basing. Now these are the about 25 to 30 parameters have been drawn, like area, basin length, mean steepness, etc. And the references have been given according to the mean steep length, biometric ratio, area, perimeters. These are the area aspects that have been calculated. Radial density, steep frequency, form factor, cost of channel maintenance, shape index, texture ratio, etc. These are the relief aspects that relate to freedom characteristics. With the help of slope and DMF, we can calculate the factors: height of basin mouth, height of highest point, basin relief, relief ratio, relative relief, etc. Now, after that, we have prepared the DM map by using 30 meter instead of as per DM, and it shows at the north side there is the highest point, and at the southern point is the coming to this, and it is the data drainage. Now, this is a slope analysis by 4 different classes, 5 different classes according to the slope: 1 degree to 4 degrees, 4 to 8 degrees, 8 to 12 degrees, 12 to 15 degrees, and 14 to 20 degrees. And it shows the highest is towards the north part and lowest to the south part. Now, after that, for hydrological parameter, we have done volumetric and depth to water level and seasonal water fluctuation maps for the post-monsoon 21 and pre-monsoon 22 have been made, and there are about 8 to 9 divisions have been made. According we have drawn the water fluctuation map, and here we have made the 4 divisions: below 1.7 is poor, 1.7 to 2.5, and it is from the draft of these highest and lowest fluctuation levels. So there are 4 divisions: low fluctuation, low fluctuations, moderate fluctuation, and high fluctuation. This is for the Acharpur Talikula, and from this we have calculated this. We have divided the village category. Low fluctuations, how many villages are there? Low fluctuations, about 15 to 20 villages. Moderate fluctuations and high fluctuations, about 6 to 7 villages. And from this we have concluded that groundwater fluctuation is categorized into 4 zones: poor, low, moderate, and high fluctuation zone. And based on the findings, village-wise scattering are was prepared. And observation indicates that the majority of villages come under low and moderate fluctuation zones, indicating good groundwater availability. There is less fluctuation, less than 1.5. The present analysis shows that the villages with high moderate zones will need more water resources in future. As the drawdown is more and more, the fluctuation is also more. For countering this, effective planning, management, and economic techniques like nagabanding, KTVR, check dams, cement mandara can be suggested in various parts of that area so that the water level can be maintained, and it Thank you.
Okay.
Department of Geography. Now I am going to present about the micro irrigation technologies, where it is more useful and more convenient and more advantageous, particularly in outflow areas, where the water is very shortage, water sources are very limited, and water sources are very limited. So in that situations, in that geographical locations, so we can go for the micro irrigation techniques, so which is very considerable and very useful. So here, if we take into the consideration of India, Indian agriculture is totally depending on the monsoon systems. So if the monsoons are started, the entire farmers, that is farmer friends, are able to proceed for the cropping and all. So some parts of India, if we take into the consideration that the drought-prone areas and water is very limited, irrigation water is very scarce, and even the underground water is deployed and very deeper and deeper, and even in some of our areas, the farmers have committed suicide even. So by constructing a number of wells, that is tube wells, so one by one, which are being failed one by one. So that's in that scenario, the underground water sources are so exploited, and even some farmers have committed suicide. So here, if we take into the consideration that for producing of different crop products and also the yieldings, if we take into the consideration, we have to invest more and more amount of water, so which is very difficult, particularly in rural areas. So this is a picture which explains about the what we call is so for producing of different commodities, that is crop products. See here, the micro irrigation techniques are mainly meant. So previously, the micro irrigation techniques were not introduced. Water used to flood. That is, we used to flood the land, but not the crop. So that was the main source. So that's why more amount of water was uselessly wasted. So rather than using the amount of water which is required by the plant or any crop. So see here, we can see that so flooded the water. Even in the plantation crop, if you see here, this plantation crop, that is a banana. So the water is flooded. Generally that water flood, water supply will be in the form of flood, will be particularly in the paddy cultivation. But whereas here, in some areas, you can see the flooding of the crop, flooding of the soil is what we can call as crop. So here, wasteful surface irrigation water is particularly in the drought-prone areas. So if you take into the consideration, paddy requires this much amount of rainfall conditions. If we take into the consideration, particularly it varies from Kharif to Rabi, and it comes from paddy to the different crops. Say groundnut is needed less amount of percentage, what we can call as rain-fed crop. Then, so here, if we take into the consideration, with the help of micro irrigation techniques, even we can avoid the crop, that is what we can call is crop water requirement, and losses can be abundantly, what we can say is we can avoid or we can save the water. Losses can be taken into the consideration, and losses very drastically reduced by applying this what we can call is this formula, that is water requirement will be, that is we can be having in the surface, particularly surface irrigation, this much amount of losses we can find. But runoff can be avoided in the case of micro irrigation techniques. So micro irrigation innovations, particularly if you take into consideration, that is if you take into consideration per crop, more crop. So supplying water very little amount and drop by drop and cultivating more area. So bringing more area under cultivation with less amount of water, which is irrigation, micro irrigation technique. So this is that is what I think majority might be knowing that what is the micro irrigation technique.
surface and subsurface systems, we can have the that is the micro irrigation systems. So particularly surface on the that is near to the root of the plant, and subsurface even. So without even observing on the surface, that can be deeply inside the subsurface, and so that the water can be minimized, that is utilization. Water directly go to the what we can call as a plant instead of going to the soil. So here the attributes will be controlled application. Then high what we can call as soil water potential. Then that is what we can call as here partial soil mapping. This is the most important attribute. Next, that is maintaining foliage, using of low quality water, that is low quality water, energy efficient, and fertigation, that is irrigation. Both can be done with the help of micro irrigation. And that is the beauty of this micro irrigation technique. Adaptation of marginal water, adaptation to landscape irrigation, adaptation to produce, that is what we can call as protected crops. So then, at the national level, PMKSY, that is Pradhan Mantri Sanchay Yojana, per track, more track, so that scheme has been launched by the central government, and it is adapted with the cooperation with the state governments, and by using the different types of geospatial technologies. And here, this is an example that geospatial technologies can be used only for the, here shown for the, that is what we will call assets using geospatial technologies. But not only assets, but also we can have a mapper, we can have the area calculated, we can have the, say for example, if you take the areas which are not covered under the micro irrigation, and so many can be done with the help of geospatial technologies. So these are all the stations where we can have this PMKSY PDM, which is assets centers. And here, this is the study area, my study area, and which is located in the southernmost part of Andhra Pradesh, and which comes into the Rashtrasant area, which is the one of the driest area and the drought-prone area. So recognized as a geologist and Department of Science and Technology. And here in district, if you say, so out of the 10 years, if you take normal rainfall, so 5 years is less than the normal rainfall, where we can see the crop failures. So because of this reason, and here, if you take into consideration, the micro irrigation project has been started by the ABMID, that is the micro irrigation department, Andhra Pradesh State. And let's see how many, see if you take into consideration here, that let's see, in the case of the ST farmers, in the initial stage, only 5 farmers were interested, and it goes to the nearly 6,000 farmers, and totally went to the nearly some lakhs of farmers. If you take into the consideration, here you see, it went to the 1.9 lakh hectares under the expiry in the one district itself by the year 2018 and 19. And here, if you see, if you take into the consideration, so last before the pandemic, it was sector-wise action plans were made, and 100% it was reached. So horticulture, agriculture, agriculture, and even sugarcane. And here, in my study, I have taken some that is field verifications, and here you can see the success stories of irrigation innovation, particularly in the rural areas, and the difference they made with the flooded that is irrigation system, the micro irrigation system. You can see here, see the banana was cultivated with the help of this micro irrigation technique, and here you can see is the variation. Additional income we earn. So by applying this method, by using less sources of water in this case, that is in the case of banana, and you see that is flower cultivation. So here, nearly, if you take into the consideration, here nearly 1 lakh extra annual income, that is crop income itself, this farmer has and they got very good results with the help of this one. And we think that micro irrigation cannot be possible for the principal crops like sugarcane and paddy. And here it is very interestingly you can see here. Additionally, this farmer got 1,15,000 additional income by adopting this micro irrigation techniques with the help of this by cultivating this sugarcane. Then you see here the fruit cultivation. In the case of the fruit cultivation, now most of the fruit cultivation farmers have gone for this micro irrigation techniques. Mango, papaya, even pomegranate. So the other, even tomato also. Tomato, most of the tomato is cultivated previously in the rainfed, but now they are cultivating under irrigation by using this technique. See here, by cultivating this fruit, so he is able to, this particular farmer is able to obtain nearly 1,34,000 rupees additional income. So this is another success story we can say. And here, the vegetables. Vegetables, if you see here, see vegetables, he cultivated and he applied nearly 5,42,000, 5.42 lakhs additional income he applied by cultivating carrot under the micro irrigation technique. See here, mulberry also cultivated. This is also a real story. And here you can see one of the field by experimental method they have cultivated even paddy also under the micro irrigation techniques, and successfully they cultivated and they got the what we can call is good growth as well as the ripening stage. But what happened in this case, at the time of ripening stage, borewell got repaired. The borewell got repaired, and that is why the crop was damaged somewhat from the well. Otherwise, you would have got so better sources and better income sources by adapting this micro irrigation techniques. So here, one thing is that micro irrigation techniques has to be taken into the consideration in each and every drought prone areas and dry areas where the rainfall is the main source. That there is less amount of water, with less amount of water resources like the surface water as well as the groundwater. So we can go for the better innovations and we can bring them more amount of area under the cultivation. So with this, I conclude my presentation. Thank you very much. There is a provision that if farmer is able to invest 10%, say for example 1 lakh is the cost of installation of this micro irrigation, 90% is given a subsidy by the government. So while selecting itself, the authorities have selected the concerned categories. That is the procedure.
If there are any discrimination?
No, sir. No, that is even in the bylaws itself. So every category has to take into consideration. So including scheduled caste, scheduled tribe, backward caste and others. So more preference is given to the scheduled caste and scheduled tribe farmers rather than the even 90% is the what we call subsidy for the ST and ST farmers, whereas 50% only for the other farmers. So 75% is the subsidy for the backward class farmers rather than the 90%.
That was United Nations Earth Summit 2000. We wanted to reduce the racial discrimination, and we should not encourage this kind of discrimination. And we should.
Here one thing that the farmers like the scheduled caste and scheduled tribe, majority farmers are not able to offer the what we can say is this cost. The local conditions, that's the socio-economic conditions that have taken into consideration. No, not like that. Those who are not able to offer to install these micro irrigation techniques, they are helping by the government.
Okay, may I thank you?
Yeah, thank you.
The geological map, this is geomorphological map showing descended plateau and plateau mainly. This is plateau and descended plateau. Rest are very negligible features. Then these are the formulas by which we have carried out these calculations. This is relief ratio, density, and all this. We can see with highlighted values where we can see a slight deviation, which is because of the change in topography. So my conclusion is the watershed is divided into 4 subwaters, that is SW1, SW2, 3, 4. In this, the bifurcation ratio is between 2 to 7.66, which indicates strong structural and ecological control. Then the relief ratio is ranging between 1.89 to 9.27. These values relief is very high in the area, moderate to high. Then drainage density is ranging between 2.01 to 2.76, indicating the hard rock. Then drainage texture is 3.16 to 6.02, revealing the resistant permeable ecology. Stream frequency is between 2.01 to 2.76, exhibiting positive correlation between drainage density. Then the value of form factor, which is very less than 0.78, indicating the elongated shape of the all 4 subwatersheds. Again, the circulatory ratio also confirms the shape of the subwatershed, which is elongated. Only the SW1 is more than 0.5, so it is subcircular in shape. And again, the elongation ratio, which are very less, so the subwatersheds are in elongated shape. And the most important finding is the discharge of runoff is very low in the area. And main significance of this watershed is it is in the overexploited state, and there are no industries as such in the area. So we can say that the agricultural cropping pattern is causing this state. So this is the inference of my study.
Thank you. So next paper Mr. Singh on coastal development study.
India's journey till right now. When actually India got independent, there was actually 2 levels of governance, one at the central level and one at the state level. But when the Panchayati Raj system came in India, this Panchayati Raj system, it has given the power to the Gram Panchayat people, to the local people to take the decision for themselves. And this Atal Bhujal Agreement actually speaks on that. It is actually empowering the community, empowering the Gram Panchayat, empowering the actually people from the villages to manage their own groundwater resources. Because time is little less, so I will make it fun. Yes, sir? Yeah. So I will just back up. Yeah. So this is Atal Bhujal Agreement. It is a government scheme of 6,000 crore. There are about 80 districts in from the 7 states. And the objective is to manage groundwater. So these are actually the districts, these are actually 7 states under Atal Bhujal Agreement. And the various activities which have been taken up is the awareness activity, training activity, capacity building, and the productivity plan for the Gram Panchayat, which will be implemented, which will be executed by the government departments. These are by DLI, these are basically the incentive amount which will be given to the states for doing better work. These are some of the activities. There n number of instruments are being purchased by the states. It includes construction of piezometer, monitoring of water quality, rain gauge stations, water level indicators on that. So all these Gram Panchayat, they will be given these instruments to have actually the monitoring of their own Gram Panchayat, monitoring of the groundwater level data, monitoring of rainfall data, and prepare the budget for their Gram Panchayats. Once they are actually well aware about their own water, then they can manage their own water in a better way. So under Atal Yojana, the Gram Panchayats, they are actually preparing the water security plans for their own Gram Panchayat. These plans will be prepared by the Village Water and Sanitation Committee, which are constituted under Jal Jeevan Mission, and then all the Gram Panchayat people also, community will be involved, women will be involved, they will be also constituted, and then when they will prepare their water security plan, it will be given to the government departments, and the concerned department, it will be agriculture, it will be irrigation department, all these parallel department, line department, they will be actually doing the work which are proposed in this water security plan. So for capacity building of at the Gram Panchayat level, number of training material, number of content, number of trainings are being organized, and then they are being told how actually what is the groundwater, how it occurs, how it has to be managed, how the budget is to be prepared. So these activities, they are actually being taken up at the national level. There is a portal also, a digital portal, under which all the Gram Panchayats from all these 7 states, they will be submitting their water security plan, and they will be reviewed at the national level in this portal. So far actually, this is actually program was launched in April 2020. Now actually 2.5 years is over, and many of the activities have been accomplished. It includes capacity building at the Gram Panchayat level, capacity building at the block level, at the district level, at the state level. Then a number of IC activities, all the state program management units, they are also strengthened. And these are some of the key achievements. The progress is going on. The project is likely to be completed by March 2025. So it is a 5-year project. And actually, this is one of the most important slides. Our sustainable development goals, which are actually proposed by the United Nations. This sustainable goal number 6, number 5, and number 2. All actually Atal Yojana is actually supporting to achieve these goals set up by the United Nations. These are some of the IC activities under Atal Yojana in all the 7 states. And there are actually some challenges also. When actually we become independent, and in the last 75 years, India has gone most of the time for supply side intervention, construction of big dams, construction of check dams, construction of percolation tanks. But now the time is for demand side management. We have constructed a number of structures, but we have never told to the people what is the science, how it is to be used to the common villagers, to the people of the Gram Panchayat. So now actually we are focusing on demand side management, adoption of micro irrigation practices and all that. Yes, sir. So yes. Thank you.
Views of the share with you one thing. I am probably the oldest member in this family. I will be 85 in another 4 months' time. Asking all young people, boys and girls, some of them may be slightly maybe around 70. So I feel very energized. Thank you all of you for remembering me, recognizing me, and giving me the respect, love, and thank you.
Thank you, sir, for giving me the chance where they will receive. But some of the papers which where I wanted to put the questions, particularly from back debate. instead of doing my question was to Sir, General Sir, because when we carried out many experiments where we found that if we are buying 1 liter of distillery, cost about 22 rupees, but when we try to recharge it, so potential was my point. In this session, there were 2 lectures or presentation, particularly for orthometric analysis, one on Pili River and another on watershed from the Nagpur district. But another good presentation was by Tukadoji Maharaj. He gave the total review of culture, the challenges he put out. He also tried to say about take out and way forward. The very first lecture was the importance of special autocorrection. That is the tool which is I feel which is very or it is most required nowadays. Only thing is that the field checkups are again more important in that case. Second paper was by Priyanka Shukla from Simper, another lucid presentation by her. Then Dr. Nirmala D'Souza, she also presented data on the cyclone, but I feel that there should be some synonyms when the cyclone is on the way. When it is in the ocean, some another word should be there, but when it comes on the land, particularly when she was talking about Delhi, so there should be another terminology or synonyms which is more important than it would be more important. And another important slide, she presented that 40% increase of rainfall in India. So question arises in mind that what will happen to paddy fields, or what would be the future for the paddy fields, whether it will increase or decrease. And another question comes in mind, that what will happen to the landforms after the changes in the cyclone. This 40% of rainfall, that will convert, there will be more conversion of landforms, but yet another good presentation. Yeah, that's a final from my side. Thank you to all the presenters for the very useful
express my sincere thanks to organizers, particularly Atul sir, giving us this opportunity to be sitting in front of us. Thank you very much.